In this video, I will test something we have been doing in Lake Furesø for 20 years now. We have added oxygen to fight pollution, to make algae away and make the water clear again. But here's the question. What actually happens if we turn the oxygen off? Lake Furesø is the deepest lake in Denmark, 37 meters. Years ago, it was a clear lake with underwater meadows of stonewort plants. You could see fish swimming 8 meters down. Then the town grew. Houses were built, suburbs spread, and their wastewater was poured into the lake. The Sækkerdijk dropped from 6 meters to just 2. To avoid things getting worse, like algae blooms, oxygen depletion, and fish kills, wastewater was diverted and treated in the 1970s. But the lake did not recover. Sækkerdijk stayed at 2 meters. Biologists explain this by phosphorus stored in a lake mud from earlier wastewater loads. Each summer, when oxygen disappeared from deep water, this phosphorus released from the mud and fed new algae. To solve this problem, the communities decided to oxygenate. Large oxygen tanks were installed. Pure oxygen was led through pipes to diffusers on a lake bottom and released as microbubbles into deep water during summer. The theory behind all of this is that oxygen is supposed to stop phosphorus from leaving the mud, and less phosphorus means algae away and clear water. It's called the oxygen-bind phosphorus theory. It has been accepted truth in freshwater biology more than 50 years. The theory is based on measurements. When oxygen disappears, iron and phosphate dissolve from mud and enter the water. When oxygen returns, iron and phosphate again precipitate as insoluble iron phosphate in mud. Because these things happen together, we concluded that oxygen is what controls phosphorus release. Now we are ready to do the test. We use the mass balance equation to calculate lake's pool of dissolved phosphorus from inflow, release from mud, sedimentation into mud, and outflow of phosphorus from the lake. All of these values are known from measurements. The mass balance works the same way as a bank account. What comes in, what goes out, and what remains. We can let Excel spreadsheet do the math and even make it draw curves to show the balance over time. Now we can perform a hypothesis test. We treat the lake oxygenation as a full-scale experiment and use a mass balance to test the theory. For this, we calculate 2 scenarios. First, a no-effect scenario, what we expect in a normal lake, and second, an oxygen-bind phosphorus scenario, assuming no phosphorus release from the mud. Now let's hit the start button. Here's the full test result. To reach a conclusion, we compare the 2 scenarios with the measured phosphorus pool in the lake. That's the dots in the figure. The no-effect scenario has the best fit The oxygen-bind phosphorus scenario, no fit at all. We also calculated phosphorus in deep waters from measurements. Gray bars show the phosphorus pool in spring, and dark bars the increase during summer by release from mud. This release is exactly what oxygen was supposed to prevent, and it did not. So again, the theory not confirmed. Notice the hump midways in the phosphorus curve. This hump, I believe, comes from storm overflows from the sewer system during heavy rains. It appears the sewer system has now been fixed to prevent overflows from getting into the lake. So we were wrong. The oxygen-bind phosphorus theory was not confirmed. But what then is wrong with the theory? After all, it was supported by many measurements. The answer I found in an article from the IAVAG Institute in Switzerland. Their researcher, Dr. René Gechter, performed the hypothesis test on 2 deep Swiss lakes that were also oxygenated. In fact, it was his test I did on Lake Furesø and got the same result. Theory not confirmed. Dr. Gechter took it a step further. He performed experiments to solve the puzzle. He found that oxygen does not bind phosphorus as iron phosphate in mud, but that instead 2 independent processes are at work. First process, iron dissolves if no oxygen and precipitates as rust in mud when water has oxygen. Second process, bacteria release phosphorus if no oxygen and take it up in their cells when water has oxygen. These bacteria are called polyphosphate bacteria. We use them in wastewater treatment plants to remove phosphate from sewage. The cells in our body also use polyphosphate. The molecule is kind of a biological battery that can charge with energy from digesting our food and release that energy when it's needed for life processes elsewhere in our body. The molecule is called ATP. The energy is stored in bonds between phosphates in the molecule. So the 2 processes, iron dissolving and phosphorus dissolving, are not connected in a way that one causes the other, as biologists have believed and interpreted. This is a classic example of a false conclusion. Correlation is not causation. Because 2 things happen at the same time is no proof they are connected and that one causes the other. For example, when ice cream sales peak at the beach, people also spot more sharks, and that correlation is no proof that ice cream attracts sharks. But for 50 years, we made the same mistake about iron and phosphorus in lakes, and even today, many of us still believe. Same kind of mistake. Clear water lakes have oxygen in water. Does not prove that oxygen makes lake water clear. Here's René Gechter's article about oxygen having no effect on phosphorus and algae in lakes, and another article that questions the oxygen-bind phosphorus theory. Now let's get back to our first question. What happens if we turn the oxygen off? Well, the answer appears to be nothing. Oxygen has no effect on Lake's phosphorus pool. What has effect is that we stop pollution and then wait. Wait for phosphorus to flush out without flow and to sediment permanently in bottom mud. In Lake Furesø and in the Swiss lakes, this took about 20 years. Oxygenating or not makes no difference.